Section 5, we finally get to our graphing section of the chapter. We're going to graph square root functions and cube root functions. Now, square root is the inverse of a squaring something, right? And squaring things gave us parabolas. So a square root function is going to be similar to a parabola, but it'll look a little bit different. Let's look first at just y equals square root of x. So nothing fancy, just plain square root of x. And let's graph this by plotting some points. So what points should we plug in? Well, maybe let's just start with 0. Square root of 0 is 0. So we have a point there. Now we can't go left because we can't do the square roots of negatives. We're plotting this on the real coordinate plane, so we're not going to worry about the imaginary numbers that we've talked about before. Can't do the square roots of negatives here, so we don't even worry about anything to the left. So let's go to the right. Square root of 1 is 1. Square root of 2, not 100% sure what that is. That's some decimal, right? So let's jump forward to 4. Square root of 4 is 2. The next nice point to plug in would be a 9, so jump forward to 9, and square root of 9 is 3, right? So there we go. And if we draw through these, makes a nice curved shape, which is essentially half of a parabola. If you were to turn your screen sideways, it would look just like a parabola where you have, if you turn it sideways, on the bottom you'd have the numbers you plug in, and the squares going up, getting further away. Okay, so square root makes this little half of a parabola, essentially. The only way that we could get the bottom half of the parabola is if we were to put a negative in front of the square root sign. Then we could graph the bottom half of that parabola, but we would only have the bottom half, not the top anymore. Now we won't just always get the plain square root of x. We can add things in there. We can multiply. We can add things into different places. So we're going to graph these using the same a, h, and k method that we have before. Maybe we multiply something at the front of our square root. That's the a. Maybe we add or subtract something inside the square root. That's the h. Maybe we add or subtract something at the end of that equation. That's our k. And these do the same exact things that they've done every time that we've used them before, for absolute values, for parabolas. Okay, so they're going to do the same thing. So hopefully you could probably fill this out on your own, but recall that a does whether it's positive or negative. So this could either give us the top half of that parabola if it's positive. If it's negative, then it would give us the bottom half. So we could put that a gives us the top / bottom half. But then a also, if it's a large number, will stretch it up faster. If it's a fraction, it would pull that half of the parabola and make it narrower. It would make those values smaller than what they are. So it could stretch it up, I guess, or we could say shrink down, and I think we'll see an example of each. It's kind of like our slope. We'll use it to help us out, kind of like a slope at the start of our graph. H is our left / right shift. And remember, again, that's opposite what we see. So when we see x minus 2, that shifts us to the right 2. If we see x plus 2, that will shift us to the left 2. And then k is our up or down shift. And that one is exactly what we see. Let's start with an example. Y equals negative square root of x minus 3 minus 2. So first thing to do is find our starting point, to find our vertex. So our starting point is moved right 3 and down 2, so right 3, down 2. So our vertex is at 3, negative 2. And then that's it for those two. Now we just need to figure out what direction it opens and how it's stretched or shrinked. And that's all up to A. So A is a negative 1. Since it's negative, we're going to have the bottom half. We're going to have the bottom side of our parabola. It's going to seem like it's opening and pointing down. And then it's a 1, so it's a negative 1. So that's not going to change the shape of our graph at all. So we can use that value of 1 pretty much like a slope. So we know we're going to be going down. We're going to have the bottom half of that parabola, so it's going to go something like that. But exactly how? We can use that 1 kind of as a slope and go down 1 over 1, just like we would if it were a slope. And I'm happy with just those 2 points. We know we're going to go down through that one and curve out to the right. So there is our graph of negative square root of x minus 3 minus 2. One more quick, let's look at y equals 3 square root of x plus 2 plus 1. That plus 2 is going to shift us left 2, plus 1 moves us up 1. So our vertex is going to be at negative 2, 1. And then we have a positive 3 in front, so it's positive, so we're going to have the top half, right? And then that 3 is going to stretch it up faster. It's going to make all of our values 3 times more than what they would be. So to get ourselves started from our point that we plotted at negative 2, 1, treat it like we're going a slope of positive 3 from there. And then that kind of shows us that it's going to be steeper. And so we can draw a graph of our square root through there. As long as you get something roughly through those 2 points, I'll be happy. Okay.